We're talking about heat and temperature today. Okay. Molecules move around and vibrate rapidly in all directions. That disorganized energy is referred to as heat. Okay, so everything has a temperature or some type of heat to it there. Heat and temperature, they're not the same. A lot of times, what's the temperature of something? What's the heat of something? Heat and temperature is different. Temperature is how cool or how warm an object feels. That's the temperature of it. It's the measure of the level of energy there, of heat energy in there. That temperature is actually measured in degrees. 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 Okay? Temperature is measured in degrees. Heat is measured in calories. Okay? Metric unit called calories. It expresses the amount of heat needed to raise the temperature of 1 gram of water 1 degree Celsius. So that's heat. Measure 1 gram of water. 1 gram of water. 1 degree Celsius. So we're going to increase it. 1 degree Celsius. 1 degree Celsius. Yep. So 1 gram of water, 1 degree Celsius. Let's just put a degree sign there, even though it's not really necessary for Celsius. We just use the capital C there and we'll be good. We might just edit this out, but we'll see. For calories, 1 gram of water, 1 degree. 1 gram of water is not a large amount of water, but we go to increase that 1 degree. It takes a calorie of energy. Okay. British thermal units is another way we actually measure heat. So BTUs, if you've done the HVAC system in your house, you say, well, how big is the unit? How many BTUs of heat energy does the thing move? British thermal units, BTUs, British thermal units, is the heat required to raise the temperature of 1 pound of water 1 degree Fahrenheit. So you can see metric and imperial, so to speak there. 1 pound of water, 1 pound of water, and let's see, that's the hashtag symbol. I know. I'll just do the LV, okay? 1 pound of water, 1 degree Fahrenheit. Okay, that's a BTU. 1 BTU can raise 1 pound of water 1 degree Fahrenheit at sea level. Sea level changes things when it comes to heat and temperature. Boiling point and things like that, for those of you in Denver and Colorado and places that are really high. Yeah, it changes things. So at sea level, that's what it is. 1 BTU equals 252 calories. So 1 BTU is equal to 252 calories. So 1 pound of water, 1 degree Fahrenheit. But 1 BTU equals 252 calories. So, just so you know, 1 BTU equals 252 calories there. Sensible heat. We know what sensible heat is. Sensible heat is the heat you feel. It's sensible. You can feel it. You can touch it. I can pick up a piece of ice and I can feel the heat in that. That's 32 degrees worth of heat that it has in there. When we build a bonfire, a campfire, it gets warm. You know, our heating and air conditioning systems there. The battery on my laptop as it gets warm. The lights here around me kind of get warm. However, they're LEDs, so they're not really getting that warm. But they actually have sensible heat. If I touch it, I can feel a difference in temperature. It's not room temperature, a little bit higher than that. That's sensible heat. Because we can measure that with a thermometer. Sensible heat, we measure that with a thermometer. So sensible heat, which is in the name, sensible heat, is measured with a thermometer. So we can measure that with a thermometer. So, and I did not spell sensible right. I didn't realize that. I said, that didn't look right. Sensible heat. And some of you are like, well, it's automotive. You don't really have to spell right. If I could tell you the number of owners of shops who want you to be able to spell things correctly when you're writing out a repair order, it means a lot. Spell check is your friend. I don't have spell check on my light board here. However, but sensible heat is measured with a thermometer. When you sit here and take temperature with something, I actually have my daughter's thermometer right here. It's right here. You stick it in your tongue. Do whatever you want to with it, where you want to put it there. It's measuring sensible heat. It's saying it's low heat right now. But this is the thermometer is measuring sensible heat. I've got other thermometers over here. We'll talk about those in a little bit. But that's what we use to measure sensible heat. When we're doing heating and air conditioning, we're going to use thermometers. We're going to measure sensible heat. How hot is the heat getting? How cold is the air getting? Or how much air is the air conditioning moving? So regardless, we're going to actually measure that in sensible heat. We're going to measure that with a thermometer there. Latent heat, okay, that's sensible heat. Latent heat, I want to change colors on this one here because this is a big thing that you need to understand here. Latent heat. This is the heat you can't feel. This is the heat that causes a change to occur, a change in state. When you're going from solid to a liquid, from a liquid to a solid, if I'm sitting here taking ice, taking water at 32 degrees, it doesn't instantly become ice at 32 degrees, right? If that was the case, we could just sit here and just pour a glass of water there, stick in the freezer, and then 5 minutes later it'd be cold, it'd be frozen. We have that sensible heat, and latent heat is different. Sensible heat is what we can feel. Ice is always 32 degrees. However, latent heat is the extra heat that it takes to actually do the work, to freeze the water or to cause the water to boil. That's the latent heat there. I'm looking down here because I just want to make sure this is right. The water in a container of the stove boils at a temperature 212 degrees at sea level. For as long as any liquid water remains, it's only going to get 212 degrees. It's now going to get hotter than 212 degrees as long as it continues to boil there at sea level. As heat is further added to the water, heat can be used in the changing of state from a liquid to a vapor. This extra hidden heat, which is your latent heat, which is necessary to change the state of a substance. It's going from a liquid to a vapor. That latent heat has actually caused that to happen. That latent heat is what causes liquid water to become ice, is that latent heat. It's important in the operation of an air conditioning system because the cooling effect is derived from the changing state of liquid refrigerant to a vapor. That's why we're talking about the heat and temperature and sensible and latent heat, is because what we want you to use, the refrigerant we're talking about in the automobile, either be R12, R134, or R1234YF. Whatever type of refrigerant you've got in your vehicle here, it all works similarly. It's all about the liquid refrigerant turning to a vapor and then condensing back to a liquid. It's vaporizing, it's condensing. That's what's happening. The changing of state there, that latent heat energy is how we get the air cooler in the vehicle. So just be aware of that. So heat and temperature are different. Heat is measured in calories, British thermal units. Temperature is measured in degrees. So when we take your temperature, you're actually good with degrees, but we have heat in us there, and we have sensible heat, which is the heat we can feel, and latent heat is the heat of change. So hopefully you'll get that concept. If not, we'll talk about it a little more in class or in the lab. And if we have a collaborate session where we're talking about this, please feel free to ask questions. Google this right here. Get good information. That's the trick, is getting good information. But I just wanted to give you a heads up on this.